Hello everyone, welcome to my YouTube channel Physics in a Nutshell and welcome to one more new video, right? Today we're going to basically discuss one new lesson of your physics part of class 9. Till now we actually completed two lessons. First lesson was what? Motion, and the second lesson was forces and laws of motion. Basically, before starting this lesson, just let's recall what we have actually learned in the first and second lesson. In the first lesson, what we have actually discussed, mainly because all about what? Motion. Right? And what that motion is nothing but what? Change of position. Again, regarding that motion, we also got what? Velocity, acceleration, speed. Clear? Right? The second lesson, which is nothing but what? Forces and laws of motion, right? In that lesson, what we have actually got? That how force actually impact the motion of something. Okay? Motion means what? There is also a rest motion. That means if certain object is at rest, okay, if there's no force like that, what is going to happen? I'm always going to be at rest. That means what? Force can actually change my motion. Right? And which motion is that? Rest motion. Again, if some car is actually moving at a certain speed, okay, if there is some extra amount of force is there from the opposite direction, then what is going to happen? That force is applicable to stop that motion, right? And that's how basically force works, right? In the first two lessons, we have basically discussed how motion and force is the laws of motion and how force is going to act that motion. Clear? Now, in this today's video, we are going to basically discuss about one new type of force that actually you have not got earlier. Okay, this is a whole new part or whole new concept for you. But in the last video where I actually discussed some exercises of the last lesson, is about what? Forces and laws of motion. I did one problem regarding your forces and laws of motion, but where I did problems like that, if I drop a ball, okay, from a certain height, it is going to fall in the ground, right? There's a certain problem like that. So I told you in the last video that it happens because of gravitational force, okay? So now we are going to mainly discuss how that actually works. See, we always observe certain phenomena in our day-to-day life, okay? If you just lift something from a certain height, it's going to be there. It is not going to move upward, it's always going to move downward. Why? First question. Secondly, we always observe that our moon is continuously revolving around what? Our Earth, right? Considering that our Earth is the center and that moon is continuously revolving around the what? Earth. And our Earth and along with other planets in our solar system only, those planets including our Earth is continuously revolving in an elliptical path, okay? Elliptical path is continuously revolving around the sun. We also know that these are certain things that you are actually observing here. Why that or how that moon is actually revolving around the what? Earth. Again, you are just observing that the sun is continuously, along with other planets, continuously revolving around what? Sun. How? Again, we observe that some extra satellites, okay? We all have satellites. Our India have satellites. Lots of other countries have satellites. They just place the satellite outside the Earth, right? In a certain orbit, like moon. Okay, moon is our what? Natural satellite. Again, those satellites are man-made. That is known as the what? Artificial satellite, right? Those satellites are necessary if you are able to watch this what? Mobile, TV, all because of satellites, all with the help of satellites. So that's how satellite works. Again, how those satellites are able to move, right? In a circular orbit that is continuously revolving around the what? Earth. What is the force between, or what is the force there with the help of which they are actually able to move around the what? Earth? We actually now wonder about that. One great scientist, or you can say one great revolutionary scientist named as Sir Isaac Newton. Okay, he was the main person. Okay, he was the main person who actually named that force. Okay, which is, or that factor which is mainly deals with, or which is the mainly region for which we all actually observe that kind of things. Again, when you will go in higher class, we are going to actually learn that how those high tide in sea that is actually occurs because of that gravitational force. Okay, that due to that gravitational force, we are going to get high tide. Okay, due to the gravitational force, the moon is actually able to actually rotate around the what? Earth, and then due to that gravitational force, all the planets along with our Earth in our solar system, they are able to revolve around the what? Sun. Okay, that's the main fact, and that is nothing but what? Gravitational force. And along with that, okay, our lesson is to be all about gravitation. Okay, so our today's lesson is nothing but your next chapter is nothing but what? Gravitation. Okay, now let's start it. what actually gravitation is, how it is actually work, okay, how we are going to deal with that. We will discuss everything. So don't worry about anything, just be with my video. By the way, if you're just new to this channel, if you like my way of teaching, just subscribe to it, okay, and hit the like button, okay. This likes and subscriber is going to give me motivation to make lots of videos like that, okay. And I am always here. I am gonna make lots of videos for you in upcoming times too, okay. So just be with me. To start this lesson, gravitation, we will first consider one example, okay, and this example is quite known to us, okay, and this example actually happens with the great scientist or the great physicist Sir Newton. One day while he was sitting below a apple tree, okay, what actually happened to him? We all know that an apple fall on him, okay. But if we are the normal people, what we are going to do? Yeah, it falls. What is the big thing? But he doesn't think like that. He think it deeply, okay. He then thought that why the apple only fall on me? Why does it move upward or it doesn't goes upward? What is the main reason? What is the force there that is actually attracting that apple towards the ground? One question, okay. And based on that question, he actually discovered one new thing, or actually deduced one new term, that is about gravitation, okay. That was first question. The second question is, we all know that, and you also observe that the moon is actually continuously revolving around the what? Earth, okay. Interesting fact is, since many long years, consider, I don't know how many years it is, but from long time that moon is continuously revolving like that, okay. What is the reason behind that? Why it is not actually changing its path? Why that moon is not actually getting away from the earth, okay. Why? Or why the moon is not getting away from its circular orbit, that is, it is actually revolving around it, right? It is actually, there is some kind of attraction between that earth. If you consider that, if this is our earth, okay, and if it is the orbit, okay, and this is the moon, that moon is continuously revolving around in this part for so many years. We don't even know from how many years, okay. For so many years, it is continuously revolving around this what? Earth. There may be some kind of attractive bond between the moon and the earth, okay, so that it is not actually getting away from its own orbit. Simple. Similarly, if this is the sun, okay, around it, our earth is actually moving, right now, from so many years, maybe from when it is, the earth actually born, or from that point of time, it is continuously revolving around the sun till now, okay. It is actually happening, and right now it is also happening, okay. Since we are just watching the video, that moon is continuously revolving around the earth, and our earth is continuously revolving around the sun, okay. So what can be the reasons, okay? Our great scientist Sir Isaac Newton, okay, argued with the same reason to all these problems. He argued the same reason with all these problems. That reason is about gravitation or gravitational force. Now, what is the gravitational force? Gravitational force is the force that is acting between two objects, and that force basically depends on the mass. We all know from the forces and laws of motion, we have got that F is equal to what? F is equal to ma. But for that force, okay, certain object having a mass m, and that acceleration is constant. Sorry, that mass is actually constant and acceleration is continuously changing. That means what you can say, if the acceleration increases, force is going to increase for certain object. But here what is going to actually happen, that gravitational force is going to need two objects, or for two objects masses are different, okay, right now. So that's what here, that for gravitational force of attraction or for gravitation, the masses are the main important thing, okay, for which or with which that force is going to work, okay. And masses are, if masses going to be different, okay, the force is going to be different. We are going to get that. We are going to get it. Don't worry about that. I'm going to show it with some mathematical formula, okay. So don't worry about it. We are going to move it. To understand this basic thing, okay, how moon is continuously revolving around the sun, we are going to take one example. Okay, we'll take one example. Now we'll just try to actually understand how the moon is actually able to revolve around the earth. Okay, to actually understand, first we'll consider one rope or one thread. Okay, this is one thread. This is the one end. Okay, and in the one end you're just going to hold, and in the other end we have just tied up a one stone. Okay, then what we do? We just have to wheel it like that. That means what? We are just going to rotate that stone with the help of the thread. So what is going to happen? Okay, if this is your hand and you are just going to rotate the thread like that. Okay, this is the center, and this is the thread, and this is the stone, right? This is the stone, and this is the circular part of the stone that is continuously moving around here. Okay, this is the fact. While that stone is continuously revolving around what? This part. That means while we are just doing like that, or just keep rotating that circular stone in a circular part, okay, what is going to actually happen? And what was actually happening during that circular motion? What was actually changing while you were just doing the circular motion? We actually did that, or we actually discussed that while we were discussing about the uniform circulatory motion. What actually happened? Whenever we actually discuss a uniform circular motion, what is going to actually happen? That velocity, okay, is going to change at every point in this circular part, right? We know that velocity is a what? Vector quantity. That means what? Velocity is going to depend on both magnitude and direction. Here, maybe, or though the magnitude is remaining same at every point, okay, its direction is actually changing, right? This direction continuously changing. If one of the two quantity between magnitude and direction is changes in case of velocity, the velocity is going to change. Right now, velocity is going to change. If there is change of velocity, what we can say? There is change of acceleration, right or wrong? If there is change of velocity, there is going to be what? Change of acceleration, right now. So this is one fact. We are going to get that acceleration changes, right? Acceleration is going to change. Simple fact. Again, what is going to happen if you just leave the thread from your hand? What is going to happen? The thing is going to happen that stone is going to move in a straight line. That stone is going to move in a straight line, and that maybe in this direction or maybe in this direction. Okay, and that line, okay, and that line is nothing but a tangent to this circular part. And what if you actually can represent this like that? If it is the circular part, okay, first if consider this was moving in this part. Once you leave that stone, what is going to happen? This is going to move in this direction or maybe in this direction. That line is nothing but a tangent. While you are going to in a higher class, we are going to understand the concept of tangent. Okay. Again, while we just leave that stone, okay, from our hand, it moves in this. We actually understand that. Now, before that, while it is just continuously revolving around our hand, okay, we just continuously doing like that, na? So our center was our hand, right? Here it is our hand, okay, and this is the stone, or just think some ball. You can just consider anything, okay. That stone was continuously revolving around a circular orbit or circular path. Consider our hand is at the center. Similarly, our moon also acts like that. Okay, if anyhow that force that is actually attracted, or the attractive force between the earth and moon disappears, what is going to happen? Our moon is going to move in a circular straight line path. Simple fact, right? But we now have to understand, okay, we now just do not consider the fact that the moon was going to move in a straight line. But before that, while it was actually moving in a circular path, how it was actually able to move in a circular path? Because that acceleration, we know now that acceleration is going to change. That means what? There is some kind of acceleration is there. Due to that acceleration, that moon was actually continuously revolving around the orbit or revolving around the what? Earth. But there is also some case. There is also some important factors are there. Okay. While the moon was continuously revolving around the earth, there was an actually force. That force is about what? Centripetal force. Okay. Centripetal force. That centripetal force is also known as center-seeking force. What does it mean by center-seeking force? Because it have a tendency to move towards the center. And in this case, while the moon was actually continuously revolving around the earth, what was the center? Center was nothing but what? Our earth. Right or wrong? Right now? That means that moon is having a tendency to move towards the earth. But there may be some balance condition is there. That's why that moon is not actually coming towards the center or not coming towards the earth. Right? And that force, that thing is nothing but what? Acceleration. That acceleration helps the moon to rotate or to revolve around us in a circular orbit. Okay? But if anyhow that attractive force between earth and moon disappears, what extra force is going to come in that thing or come into play? That extra force is basically known as what? That is not mentioned in your NCERT book, but you should actually know it. That force is nothing but what? centrifugal force. That centrifugal force is completely opposite to that centripetal force. Okay, while you just consider that while the attractive force between Earth and Moon disappeared, what is going to happen? That Moon is going to move in a straight line. In that case, centrifugal force comes into play. Okay, that centrifugal force is completely opposite to centripetal force. What was centripetal force? Centripetal force is that force which have a tendency to move towards the center. That's why it is known as what? Center shaking force, right? That centrifugal force have a tendency to move away from the center. Okay, that's why this force is known as what? Center fleeing force. Okay, that means it have a tendency to flee away from the center. That is known as the centrifugal force. But while that Moon was in complete rotatory motion, that centrifugal force will not be there. It will only come into act while that attractive force between the Moon and Earth disappeared. Okay, same case is here now. While we actually rotating like that now, it's just rotating like that. But once we leave that, what is going to happen? That thread was going to move like that in this direction, that is in a straight line path. In the same case, okay, in this case, while that actually stone was moving in a straight line, here was also centrifugal force was there. Centrifugal force. That centrifugal force and centripetal force. Okay, one common term is the center. Okay, and center always comes while it is a what? In a moving a circular path. Okay, centrifugal force and centripetal force only comes while an object, okay, based on certain center actually moving in a circular path. Okay, one object have to move in a circular path, then the centrifugal force and centripetal force come to act. Okay, that's how that Moon, with the help of that gravitational force that's actually acting between Moon and Earth, is actually acting due to that gravitational force, and that's why that Moon is actually able to move around the Earth. Now here is one condition. I have told that due to the centripetal, that Moon is actually able to move around the what? Earth. Right now, I told you that. But you are just maybe in confusion a little bit there. I told you earlier that there may be what? Gravitational force. Right now, gravitational force should be there. Right? If all thing happens because of gravitational force, what is how that centripetal force is responsible? Remember one thing. Due to the gravitational force, centripetal force is there. Okay? We consider that I am a Earth, okay, and I am just pulling one Moon towards me, okay, and it is not like that. You are going to get it that Moon is going to attract us too, okay, but I am attracting a Moon, right? Because of my attraction, okay, that attractive force leads to that centripetal force, okay, and since there is centripetal force, there is an equal and opposite amount of force also there. That is nothing but what? Centrifugal force. That's how all things are actually related. Okay? If there is no force, there is going to be no centripetal force. If there is no centripetal force, centrifugal force is not going to be there. Okay? This is the main concept regarding centripetal force, centrifugal force, all of the things. Okay? We all have got it. We have also got a gravitational force is nothing but what? That force actually attracting between two objects. Okay? This is not that kind of force that only one object will apply that force on the other. Okay, the two objects going to have a similar amount of force. It is going to attract on this object and this object is going to attract on this object. Okay, that's how it is going to attract. I told you that there is maybe an attractive force between Earth and what? Moon. That Moon will also attract the Earth and Earth will also attract the Moon. That's why that Moon is not getting away from the what? Earth. Is the reason. Now we have to actually check. Okay, let's take one example. Okay. That when we actually just leave something from my hand, what is going to be there? That ball or that apple, anything is going to move towards the ground, right? That means what? There is some attractive force from the ground on that ball or on that apple or anything, right? But we know from that Newton's third law of motion, okay, that whenever and there's a force acting on something, that something is going to attract that force. That means what? There's an equal and opposite force is there, right now? Consider that. Okay, first let me erase this. If I drop a ball from a certain height, okay, this is the ground. That ball will what? at a certain point it will be on the ground. That means what? That ground have some kind of attractive force on this ball, right? That means what? This is applying certain amount of attractive force on the ball. That's why that ball is in the ground now, right? But according to Newton's second law of motion, what we have got, sorry, third law of motion, what we have got, that while there is some kind of acting force is there, and that here in this case the acting force is given by what? Ground. So during that acting force, there is going to be one what? Reactive force, and that reactive force was going to be given by what? That ball. That means what we can say, this force applied by this actually apply a force in this direction. That means it is pulling it right now. So this force is actually applying in this direction. So its opposite force is going to be what? In this direction. That means what? That ball is going to give a reactive force on the ground. That means what? That ball will try to actually pull the ground too. But the thing is it really able, or is it really going to happen that ball is going to attract this ground? Okay, if I leave a ball from this position, is that ball going to attract the ground? One question. Secondly, I told you now that moon is actually continuously revolving around the earth. Is moon is able to attract the earth towards it? What do you think? Is it really possible? No, na? Because there is again one law. That law is nothing but what? Second law of motion. What second law of motion says? We got from second law of motion that F is equal to what? Ma. Okay. From here, what you can write? A equal to what? F by M. Right or wrong? What we have got that? Okay. What we have got? I will write here. We have got that F equal to Ma and A equal to F by M. That means here acceleration is inversely proportional to the what? Mass. Right now? Consider this example again. Okay, this example. Here apple or that ball is going to have very less mass compared to the ground. Our ground means what? Our earth, right? This is our main position where we are standing. So that is going to be our earth. Ground means what? Our earth. This is the ball and this is our earth. Compared to this ball, earth is going to have a more mass. Okay, M2. Here, M1 is going to be very much greater than what? M2. Okay, if we just modify this equation, what is going to be there? A1 is equal to F by M1 and A2 is going to be F by M2. Here, what is actually given? M1 is very much greater than M2. That means what? If mass becomes greater, acceleration is going to be what? Less. If mass becomes less, acceleration is going to be what? Reduce, right now. So for the mass 2 or for the ball, what is going to be acceleration is going to be higher. Right now, since the acceleration is inversely proportional to what? Mass. For the ball, mass is less. Right now, for that reason, what is actually going to happen? That acceleration of the ball is going to be higher compared to the earth. You have to understand it very deeply. That ball having a tendency or having some kind of pulling force on the ground. But that force, or due to that force, that acceleration that the ground have is quite negligible compared to the acceleration of the ball. But what you can actually understand from here, that ball is actually able to apply a force on the ground to attract towards it. Okay, but during that attraction, that acceleration that attains by the ground towards it means towards the ball is quite negligible. Okay, that means what? Negligible means what? That is actually, though it is in exist motion, but it is not going to actually what? Considerable. Okay, that is actually meant by negligible thing, right? So that's why we say that our surface is not going to move towards the ball, but that ball is going to move towards the earth. Because why? That ball is going to have a what? High amount of acceleration. And this is the same reason why the earth is not moving towards the moon, because earth is having high amount of mass compared to the moon. Right now, that means what you can say, that earth is going to have less acceleration towards the moon compared to the moon. Okay, that moon is going to have a high amount of acceleration, but the moon is not going to come into act because there is centripetal force, right? The centripetal force, and due to that acceleration, it is continuously going to move towards the what? Move around the earth. But if somehow our earth release the moon, okay, that moon is going to move in a straight line and it is move away from earth. If the moon move away from us, lots of things will be there. lots of high tides will be there. I will actually explain how moon actually causes that high tides in sea. You have to understand that. Since you are now dealing with physics, you are going to understand everything related to our this natural phenomena. Wind flow, how high tide actually occur, lots of things will be there. Okay, you have to understand that. So this is the reason why our Earth is not going towards the moon, or while just dropping a ball from a certain height, the ground is not moving towards the ball, but rather than that ball is moving towards the ground. Okay, this is the main reason. This is the why that third law and second law of motion is going to act. Okay, so this is the main fact that we actually consider. Now we have to actually discuss universal law of gravitation. But before it, you should know one thing very clearly, that our gravitational force is not like other force. Okay, this gravitational force is that kind of force that is going to act on everybody, in every object or every body in universe. Right now you're just watching my video by sitting or sleeping in a what? In a bed or in a chair. I'm just considering you're just sitting in a chair. Okay, in that case, you and your chair is going to have some kind of gravitational attraction between the two things. Right now, see, I'm now just standing here, just near that board. Right now, in this same situation, that board and me is going to have some kind of gravitational force. Okay, that means what? Between these two things, that means the board and me, there is a gravitational force of attraction. Quite interesting, nah? But we are not just actually feeling it, right? So from this, what we can say, that gravitational force is quite weak force. Okay, see, consider I'm just sticking with the board, right? That means what? I can say that there is some kind of attractive forces there. But if I want, I can actually move away from it. That means what? I need less amount of force. That is actually quite negligible amount of force that I have to apply to move away from the board. Okay, when you want, you can actually stand up on your chair. Okay, I told you now that you and your chair is going to have some kind of gravitational forces there. But since this gravitational force is quite weak force, you need less amount of force to apply to actually move or to get away from that force, or less amount of effort you have to do. Okay, so this is the fact. Consider one thing. Again, let me show you. Just try to understand properly. This is the ground. Okay, this is one ball. This is the second ball. According to the gravitational force, okay, and the concept of gravitational force says that every object in this whole universe going to have some amount of attractive force. That attractive force is about what? Gravitational force in between them, right? So these two balls is going to have some kind of attractive force between the two, right? Again, since this is the ground, right, it is also have a tendency to move downward. That means what? Again, that ball will going to attract, as I now discussed, but this attraction is quite less compared to the attraction by the ground. Okay, now though the two ball is having high amount or some kind of gravitational force between the two, okay, if I leave the two ball from a certain height, what is going to actually happen? Are they going to collide with each other due to attraction, or they will move towards the ground, or they are going to fall on the ground? Obviously they are going to fall on the ground, except that they are going to meet at a certain point, right? So what we can say, that the gravitational force applied by the ground is quite high compared to the what? The gravitational force between the two objects. Again, here mass is there. Okay, consider that force is going to have a mass. Okay, that two objects going to have a mass 1 kg and 2 kg. Okay, right now. But when we have to discuss about the gravitational force between ground and the first ball, that ground is going to have a lots of mass. Even I can actually can't consider that. Okay, maybe billion times higher than this mass. Right now, million times higher than the mass. That means what you can say, this is going to have a high amount of tendency to attract this ball. So whenever we just drop a ball or two ball from a certain height, they are not going to collide with each other. They have a natural tendency to fall on the ground, because the ground is having high amount of gravitational force on this ball. Okay, and that gravitational force is quite high compared to the gravitational force between the two balls. That's why always this kind of thing actually happens. Okay, this one maybe you have a complicacy, so I just removed your complicacy. Okay, it's a fact. Now we will move towards our universal law of gravitation. What this actually says, universal law of gravitation actually says that in universe, okay, every object attracts the other object with a force that force is actually directly proportional to the masses of the objects and inversely proportional to the square of the distance between the two objects. I hope you have not getting anything. I will just explain with mathematical things. Okay. Again, I'm gonna draw two balls, M1 and M2. Okay. According to the gravitational or universal law of gravitation, what actually says that there is going to be attractive force between these two. Okay. So this is one force and this is the other force. And by the way, remember one thing, that gravitational force always act from center to center, from the center of this body to the center of this body. Okay, but once you will get higher to higher studies, you are going to get that the center actually shifts depending on certain situation and depending on the masses. But in class 9, it is not going to be needed. You just have to understand that gravitational force always acts from center to center, from one center of a body to the other center of the body. That's how it works. Okay, so yes, now this is the how the gravitational force comes, and consider distance between the two body as d. Okay, from the universal law of gravitation, it actually says that the force that is actually continuously acting between the two body, okay, that force is directly proportional to the product of the two masses, that is m1 into m2. You know that directly proportional means what? That if the product of the two masses is going to change, according to that, the force is going to change. Okay, this is a fact. And what it actually says that it is inversely proportional to the square of the distance. That means what it's actually saying, it is inversely proportional to the square of the distance between the two objects. But here, what is the distance between the two objects? Small d. So that force is inversely proportional to the square of the distance. Right? We can write like that. So from these two things, what we can actually write? We can write F is proportional to the m1 into m2 by what? D square. We can write this, na? So what you can write, F is proportional to m1 by m1 into m2 by d square. This is the main thing we have actually understood from the universal law of gravitation. But here we have to actually remove this what? Proportionality part. Again, maybe I hope you know, whenever we have to actually remove this proportional thing, we have to actually what? Add a new constant term. Right? So here we are going to add one constant term z, capital Z. Then that proportional sign will be removed and remaining things will be same, m1 m2 by d square. Here this capital Z, okay, that capital Z is known as universal, okay, gravitational what? Constant. Universal gravitational constant. That capital Z is known as universal gravitational constant, and that constant is going to have a certain value. What was the value, or what is the value? 6.67 into 10 to the power minus 11 Newton meter square per kg square. Quite big value, right? Or it is maybe 6.673. You can also write it 6.67 to the minus of 11 Newton meter square per kg square. Okay, and this value was calculated by with some sensitive instrument, mainly by Henry Cavendish. Okay, this scientist was Henry Cavendish, who first calculated the value of capital G using some kind of sensitive instrument. Because why this we have to use sensitive instrument? Because gravitational force is quite weak force. Okay, it can be very sensitive. Okay, if I have to move from a certain object from here, again I can move. If I have to again move towards it, I can actually move. That means what? It is quite weak force. Okay, so for that we are going to need a very sensitive instrument or very sensitive source to actually calculate it. Okay, so though it is given as some 6.61 to the minus of 11, once you move towards the higher class, you are going to get that this is not an accurate value. Because why? The gravitational force is quite weak. And that instrument, though it is quite sensitive, it is not that much sensitive enough actually to give that much of constant value actually. But we have to actually consider it as a constant value. That is 6.67 to the minus of 11 Newton meter square per kg square. Clear? Again, we can actually calculate this unit. How we have got this unit? We actually calculate that. So let me just erase this something. Okay, then I will show you how we are going to get this unit. What you have got from here? F is equal to Z m1 m2 by what? D square. Okay. To calculate the unit of this thing, what you're going to do, we are going to take this part to the left side. So what is going to be there? We are just arranging something. F into D square by m1 into m2. Right? Now, what is the unit of force? We actually discussed in the last class or in the last part or in the last lesson. That is nothing but what? Newton. This is the SI unit. Okay, whenever you have to discuss some unit of some unit factor or some actually some physical quantity, you always have to discuss that unit in SI unit. Okay, here the SI unit of force is what? Newton, right? And what is the SI unit of distance? Meter. But here distance is what? In square term, that means what? The meter is going to be what? Square. Again, here's two masses, and for one mass there is going to be 1 kg, and for the other mass there is going to be 1 kg. So kg into kg is going to be what? Kg square. So what you can write from here? We can write Newton meter square per kg square. Right? That's how we have got the unit, or it's also a dimension actually. Okay, this is on a dimension. Here we have got two, though it is have a dimension Newton for meter and kg. That means we have got the dimension of force, we have got dimension of what? Mass, sorry, not mass, distance, and we have got dimension of distance. So this is the main unit of gravitational force or gravitational constant, and that constant is known as what? Universal gravitational constant. Why that name is universal given? Because it is constant in the whole universe. Wherever you go, if you go to Mars, if you go to the what? Venus, that G is going to have a constant value. It is what? 6.673 in 10⁻11 Newton meter square per kg square. Simple fact is there. Simple concept, simple thing, just make it simple. Okay, you are going to get understand it properly. Okay, so this is the thing about the universal law of gravitation. Quite interesting, na? Quite looking beautiful in the board too, right? This is beautiful. If you can make it beautiful, it again become more easy to understand. Okay, and I'm just trying my best. If you get any kind of difficulty in understanding physics, just ask me. Yeah, I will explain anything. Okay, don't worry about that. So this is the main thing about the universal law of gravitation. Now we are going to move towards our next topic. To understand this free fall, first we will consider one example. Okay, again a ball. Okay, first I am just really holding it with my hand. Okay, and this is the ground. This is the ground. Whenever I just leave the ball from here, what is going to actually happen? It is directly going to move here. Okay, that means what? Due to this gravitational attraction applied by the ground to this ball, that ball move towards the ground. Whenever there is a change in motion, okay, during the falling from a certain height, what is actually happening? There is certain change in motion. Okay, that means what? There is certain change of positions too. During the change of the position, there is going to be motion, and there is going to be what? Change of motion, there is going to be that velocity, all the terms will be there. But before that, we have to actually understand the concept of free fall, right? What actually free fall is? Whenever I actually drop a body from a certain height, okay, and if that body only going to move only with one force, that is force is what? Gravitational force, then that is known as what? Free fall. That means it is free from external force except the gravitational force, because the gravitational force is what? Natural force. It is not applied by some external source like some kind of machine, some people, like that. Okay, when I just leave the ball, I am not applying any kind of force like that. Okay, I am just simply leaving it. Okay, it is not my fault that gravitational force is actually attracting that ball. Okay, if there is no gravitational force was there, what is going to happen? That ball was going to float in the air. But since necessarily the gravitational force is present in here, present in this scenario, that ball is going to what? Going to be attracted by what? This gravitational, that ground, right? So that's why we can say that it is free from external forces and free from forces that was actually applied by some external sources. That's why you can say that this falling, okay, due to the gravitational force only is known as the what? Free fall. Okay, but though this is the falling, it doesn't matter it's free or unfree or independent or dependent, it is falling right now from a certain height. That means what? There is change in position from a certain distance to another distance, right? And there is change in motion. During this change of motion, what is actually going? It is going to change velocity, right? We are going to get a certain velocity. Okay, and velocity is only dependent on what? Magnitude and what? Direction. Velocity is dependent on these two things, magnitude and direction. Here, what is really happening? Direction is constant. Okay, it is directly moving towards in this direction. That means from upside to downside direction. But here, what is going to change? Velocity. Sorry, not velocity. Here, the magnitude is going to change. Okay. So, if I told you in earlier of this video that if one of the two quantities between magnitude and direction changes, velocity is going to change. Here, this velocity is going to change, and along with that velocity change, what we can actually relate? Acceleration. If there is change in velocity, that means consider that it is the u velocity and it is the v velocity, and obviously there is going to be some time that to reach here to there, right? So, what is going to be the acceleration? V minus u by t, right now? So, what you can say, if there is change in velocity, there is going to be what? Acceleration. But with time, acceleration again going to change, right? Or here, actually, here, we are going to say that acceleration will be constant. We will actually understand that. Okay? So, we are going to get acceleration due to the change of velocity. The acceleration that we are going to get only due to gravitational force or gravitational attraction, that acceleration known as what? Acceleration due to gravitational force or acceleration due to gravity. Okay? And that acceleration is always denominated by what? Small z. Okay? And that small z is known as what? Acceleration due to gravity or gravitational force. Okay, force. What g is known as? Acceleration due to gravity or gravitational force. Clear? We have got the z, that is gravitational acceleration. It is quite similar to the acceleration that we are going to get in a straight line while we are just moving in a car, or while we are just riding a bicycle, bike. Nothing is that. Okay, you can consider anything. That acceleration is represented by what? A. And here, due to the acceleration we are going to get due to that gravity or gravitational force, is going to be represented by what? Small z. Okay, if I consider the mass of this ball was m, okay, that m is going to get acceleration small z while moving in this direction due to the gravitational force applied by the ground. That force can be written as what? Mass into acceleration. Where what is the mass? M. And what is the acceleration? Z. So what is the total relation? F equal to what? Mg. It's quite simple to that relation that we have actually got in the motion lesson or in the what? Forces and laws of motion, that F equal to ma. That acceleration here, A was the acceleration while we applied the force by ourselves. Okay, just by pulling a car, by pushing a something. Okay, but here this acceleration Z was given by what? Ground. Okay, and that ground, that acceleration or that force is going to be natural force. Okay, that is not a madman force. Okay, so here this is the thing, or here we are going to get the same relation, but the accelerations actually, denotations are actually different. Okay, or notations are actually different. Okay, so this is the relation. Again, we have got that. Okay, again, if this is one object and ground, consider the ground as one other object, there will be one gravitational force, right? And that force is represented by what? F is equal to what? G m1. Okay, consider that it is nothing but, sorry, I have to actually change that. Just let me erase first. Okay, and that can be represented by F equal to, okay, first just let me consider some masses are there. This is M, and consider the mass of the earth as capital M. Okay, and D, and the distance between the ground and the ball is nothing but small d. Okay, so this scenario is going to give us what? Gravitational what? Force. And that force is nothing but what? Capital Z into small m into capital M by d square. This is we have got from what? Universal law of gravitation. Again, since the forces are actually same here, because this right hand side, sorry, not right hand side, left hand side is equal. So what you can write? What you can write? We can write mg equal to z m by d square. Equilibrium situation. Right now, so we can actually cut these small m's. What we can get? Z equal to capital Z into m by what? D square. This is the general formula of gravitational acceleration or acceleration due to gravity. Okay, this is a general formula for the acceleration due to gravity or gravitational acceleration, you can also say. Okay, so this is a general formula. Whenever we just consider an object near to or on the ground, okay, so in that case, that d is actually substituted by what? G m by capital R square. Okay, so here actually the object have to be on the ground or just near the ground. Okay, that ball is actually not on the ground, but it is quite near to the ground, right? So this is the fact. In that case, that actually equation is mentioned by this one, that G equal to G m by R square. Okay, and the value of G, okay, while we are just calculate it actually in the ground or near the ground, it actually remains constant. That is what? G have value of 9.8 meter per second square. Okay, while we actually discuss this gravitational acceleration or acceleration due to gravity, some objects which is quite far away from our ground, then it is going to actually vary, okay, or it is going to change because of this distance from the ground. Okay, but in a small amount, not in a very big amount. Okay, while ever, okay, that we are going to see one thing you have to actually consider. You are going to get in the later part of the video or later part of this lesson weight. Okay, but I will not discuss about that weight. See, simply if I say F equal to mg, right, and that force is actually given by what? This gravitation, that is given, this force is actually given by our ground. Okay, and since this is accelerated what? Mass. Again, this is one quantity. Again, F is equal to what? Mg. That F is depending on not only in Z, it is also depending on what? Mass. And as a whole, this mg is going to give us the weight of the object. We are going to get it. Okay, we are going to get it in the last part or the later part of this lesson. We are going to discuss it properly. Okay, this is the thing about the gravitational acceleration or the acceleration due to gravity. Again, we can actually calculate the value of G. Now, I have just told you that G having a value of 9.8 meter per second square. Again, we can calculate this. You have to use this relation. What do you have got actually? G equal to G m by what? R square. Here what? G is the gravitational constant or universal gravitational constant, and m is the mass of Earth and R is the radius of what? Earth. We have got that G is equal to how much? 6.67 into 10 to the power minus of 11 Newton meter square per kg square. Right? And what is the mass of Earth? Mass of Earth is nothing but 6 into 10 to the power 24 what? Kg. And what is the radius of Earth? R is nothing but 6.4 into 10 to the power 6 meter. Okay, if you plot all the values here, what is going to get? G is equal to 6.67 into 10 to the power minus of 11 into what you are going to get? 6 into 10 to the power 24 by 6.4 into 10 to the power 6 meter per second square, because since it is a gravitational acceleration and this gravitational acceleration is going to have a same unit as the unit of small a, okay, which is the acceleration in the straight part or circular part, like that. Okay, if you are going to solve this, you are going to get as 9.8 meter per second square. That's how actually you can consider or calculate the value of small g by putting the values of all these constants. Okay, the gravitational constant is also, it is known as constant. Mass of Earth is constant, right? And R is actually constant. Okay, but there is some condition is there that radius R of Earth is going to change from pole to equator. Okay, right now. So again, we have got that G is inversely proportional to R square. Okay, so the value of, okay, in equator the radius is high. Okay, and that pole the radius is less. So what we have got that G is inversely proportional to what? R square, right now. If R becomes less, it is going to be high. If R becomes high, it is going to be less. In equator, the radius is high. So in equator, the gravitational acceleration what? Is going to be less, right? And at pole, that radius is less. That's why at pole, this radius or this Z value is going to be high. That's how I told you now, whenever you have to actually move away from the ground to a very high extent, this is going to actually vary depending on the what? Radius. Okay, this is the concept of about free falling. Till now, we have actually discussed lots of things in this lesson. We have actually understand how the actually gravitation works. Okay, how moon is actually able to move around the Earth, okay, in a circular orbit, and it is actually continuously moving from a very long time or very long years. Okay, and our Earth is actually continuously rotating around the what? Sun in our solar system. Okay, so these are the lessons what we actually learned today, right? And then we actually learned what is about the universal law of gravitation, what actually leads to us. Okay, and it actually told us how actually two masses are actually attracted towards each other, right, with a gravitational force, right? Now then we actually understand what actually free falling is. Again, we actually calculated that value of small c. Lots of things we actually discussed today, and just go through the video again. Okay, if you get any kind of further doubts, just ask me in my comment section. Okay, if you think that I have something I have said that which is actually wrong, just again inform me in my YouTube channel. It's in my comment section. Okay, I'll be more happy. Okay, but never skip the video, because see, once you are just dealing with physics, you are going to what? You are going to need lots of concepts to understand physics. It is not like the other subjects. Okay, so you are going to need lots of concepts. You are going to have some imagination's power too. See, we do not actually have gone through what? Moon. So to understand the concept of moon, we have to actually imagine something. So that's why I told you in the first video of my YouTube channel that while we have to discuss relating to something with related to physics, you have to have some kind of imagination's power too. It's quite needed. Okay, so this is the fact. So don't skip the video from anywhere. Okay, if you just skip the video, what is going to happen? You are not going to understand anything, and you are going to ask me, so I have not understand this part, or like that. Okay, so then I will try my best to solve everything, and I'll give my best to actually explain everything. Okay, you just have to give your best to watching the videos. Okay, you are just in home, you just feel free to watch the video as you wish. Okay, so I will not make the video so long. Okay, so just stay safe. Okay, and watch the videos again and again if you have any kind of doubts are there. Okay, so फिर मिलेंगे इस समय इसी वक्त. Till then, bye bye.